Hi, this is Sudeep Panchanda from Quite Easily Done, and welcome to another videos from Know Your Boards. In the Know Your Components series, we had talked of a component which is called the 555 timer IC, which is an 8-pin IC. When we were studying about this IC, we had said that this 555 timer IC can be used in three different modes. The first being the A-stable mode, where the output of the 555 timer would not be stable in 0 or 1, so it does not have any stable state, and so the output would keep flipping from 0 to 1 and then coming back from 1 to 0, and will keep on going on this cycle. The next state we had talked of was a monostable mode, in which we said only one state of the 555 timer would be stable, which is the state 0 or the off state, and when we provide a trigger to it, the 555 timer's output would jump from the 0 state to the 1 state, will remain there for a while because it's an unstable state, and will fall back to its original stable state of 0. So we'll get a good nice pulse as an output. And then the last we talked of was a bistable state, wherein the 0 and 1 state of the 555 timer both will be stable. So when we are at the 0 state and we provide a trigger, the output would jump to 1, will remain at 1 till when we don't provide a reset input to the 555 timer, which would cause it to go back to 0. In this video, we would be talking about the 555 timer in the bistable state. We would look at the demonstration of this board which implements the bistable state, and then would deep dive into the circuit diagram. So let's get started. Here we have the board which implements the 555 timer in the bistable mode. So let's have a close look at it first. Up top over here we have is the power supply. The red ones is the positive VCC, the plus 5 volts, and the black one is the ground. On the left we have is the trigger. On the right we have the reset. So these are the two switch. We will look at them in the circuit diagram next. But these are the buttons by which I can trigger or reset the output of the 555 timer. We also have is these pins over here, from which we can use this to get input from sensors. So the output of a sensor can be used to trigger the 555 timer's output, or some other sensor can be used to reset the output of it. So let's switch on the power and look at what it does. So right now we have the 555 timer switched on and in the stable 0 state. When I press the set or the trigger button, I get the output as 1. You can see the LED glowing over here, and this will remain stable till when I don't do anything to it. Now in order to bring it back to 0, I will have to press the reset button. That's set, reset, or trigger or reset, and both these states is going to remain stable. So now let's look at the circuit diagram and understand how is it functioning. Here we are looking at the circuit diagram for a 555 bistable mode. The circuit might look complex, but let's break it down into pieces and try and understand each one of them, each of the different components that are there which composes the entire circuit diagram. Now the reason why it looks complex is because it has been designed for creating our board, which has a lot more inputs than if you're doing the same circuit on a breadboard. Let's look at first at the pin 3 over here. Pin 3 of the 555 timer was the output. So what we have is we have a resistor and an LED which will glow if the output is 1 of the 555 timer. The same output 1 goes to our output pin, which we were connecting to relays and any other device which were requiring output from the 555 timer. So this section over here is plain and simple the output. These was just the header pins for getting the power supply. These here were just the header pins for getting the power supply to the board. The pin 5, the control voltage, is what we want to keep at 0 and want to ensure that there's no noise coming in from any other electrical circuit or adapter or power supply. So we just have a capacitor over here, which is a very standard practice to do for a 555 timer. So that covers the pin 5. The pin 6, if we see, we are keeping the threshold at 0 volts, the ground.
Now this would be important for us to understand how the 555 timer is acting in the bistable mode. We'll look at a table and just remember the threshold is 0. That's it. Now the only two pins that we have left to look, so this discharge again is kept as it is. There's nothing that we have to discharge in case of a bistable. So pin 7 gets covered over there. Pin 1 and pin 8 of the 555 timer are the voltage supplies. So that covers the pin 1, 3, we don't have to talk about 2 and 4 right now, 5, 6 and 7 and 8. The only ones that we have not talked of is the pin 2 and the pin 4. Pin 2 is the trigger. If you look, by default the pin 2 is connected via resistor to the VCC, the plus 5 volts if we are giving a 5 volt supply to the board. So by default the trigger is at plus 5 volts. Let's look at this switch over here. If I press this switch, the pin 2 gets connected to the ground. Remember the circuit, the current always tries and takes the path of the low resistance. So when we press this switch, this obviously has to drop the potential and it gets to a ground state. The other thing that we have over here is a BC547, an NPN transistor. We also was an input pin for the trigger, just in case we wanted to take input from a sensor or something. If the trigger input over here was high, the transistor would get switched on, which would be equivalent to pressing this switch over here. So in either case, even if we are giving the trigger input over here as high, switching on the transistor or pressing the button, what we are doing is bringing the threshold to the trigger to 0 volts, which was otherwise at the plus VCC volts. In this case, we would be considering that as plus 5 volts. Similarly is the case for the reset. By default, the reset is connected to VCC via the resistor, which means the VCC would be as the plus VCC, the reset pin would be at the plus VCC voltage, the plus 5 volt in our case. And again, the switch, when it's pressed, it would cause the reset to come down to a voltage of 0 volts. Similarly, the reset pin would switch on if a high is given to the reset input of the board, which would switch on the transistor, NPN transistor, and would again bring the reset pin 4 of the 555 timer to 0 volts. Now what does this do to us? So this is very simple understanding. So all we are concerned about, which are the moving parts, is the pin 2 and the pin 4. The rest is constant. 3 is the output, 6 always remains 0, 1 and 8 are the power supplies, 4 is the reset, 2 is the trigger, and 5 is the control voltage, which we're just putting a capacitor for noise cancelling. So let's look at what happens in this stage when we have not pressed either of the buttons. When we have not pressed it, both the reset and the trigger would be at the plus VCC volt. And let's look at the table over here. So this was the internal diagram of 555 timer that we had looked at when we were discussing the 555 timer in details in the Know Your Component section. So if you look, we had two comparators, the comparator 1 and comparator 2. In this case, when the buttons are not pressed, the comparator 2 has a 2/3 VCC as an input to the inverting terminal over here. As you can see, the non-inverting terminal gets an input from the threshold, which is going to remain 0 in either case. So when the comparator 2 compares 3.33 volts at the inverting terminal and 0 volts at the non-inverting terminal, it will give you the output of 0. So the output at the R of the flip-flop over here would always be 0. And what we had done was, when we were pressing the threshold button, the trigger button, we were bringing the trigger to 0. Before that, the comparator 1 that we are looking at the left over here has the inverting terminal, the non-inverting terminal as 1/3 VCC because of the potential divider over here, which comes to 1.667 volts. And when we have not pressed the button, the inverting terminal of the comparator 1 gets an input voltage of 5 volts. We saw that in our circuit diagram. So now the comparator 1 is comparing 5 volts on the inverting terminal with the 1.667 volts on the non-inverting terminal, and hence would give us a 0 output. And because we had looked at the truth table for the SR flip-flop, the set and the reset both are 0, which makes our final output as whatever the output was at that stage. So if I had not triggered anything, the output would remain 0, and if the 555 timer was in a triggered state, it would remain in the 1 state. Now when we pressed the trigger, we said the voltage would go down to 0 volts. So in this case, the changes happen solely to the comparator 1 over here, which is now comparing 0 volts at the inverting terminal and 1.667 volts at the non-inverting terminal. The trigger over here on the inverting terminal and the 1.667 volts coming from the voltage divider on the non-inverting terminal, which would give the comparator 1's output as 1. Now again, the comparator output of the comparator 1 goes to the set of the flip-flop. So when S is 1, the flip-flop would get set and would give us the output as 1. So which is the output that we get at 1. So what was happening was, when we were pressing the trigger over here, the trigger button over here, the threshold would go down to 0, would bring us to this state where the output becomes 1. And as soon as we remove these, when we're not pressing the button and the 555 was already triggered, we come back to this stage over here where the state is maintained. So now the other thing is, when we do the reset, this reset is fed to the reset pin of the 555 timer. When we press that, it's plain and simple goes and resets the flip-flop. So the flip-flop, when it gets reset, the output becomes 0 again for us, which resets the output of the 555 timer at the pin 3. So just doing a very quick recap, when we were not pressing either the trigger or the reset buttons, the state would remain constant because of the truth table over here. And when we were pressing the trigger button, then the trigger voltage at the pin 2 of the 555 timer would go down to 0, causing the final output on the pin 3 of the 555 timer to go up at 1 stage. And as soon as we have removed our fingers from the trigger button, it would come back to this stable stage again. When we pressed the reset button, it was going up and resetting the flip-flop over here. So that's plain and simple 555 timer in a bistable mode.
Thank you very much for watching the video. We would love to hear your comments and feedbacks. So please write down to us in the comment section below. Let us know of your feedbacks, your questions. We'd really love to have an interaction with you and understand how are you feeling about these projects. Thank you very much.